Imagine a world where the search for extraterrestrial intelligence doesn't just look up at the stars, but down into the darkest, most pressurized parts of our own oceans. Could the secret to finding aliens be hidden 1 kilometer beneath the ocean floor, or even within the rhythmic, haunting thrums of a humpback whale during the dead of night? It sounds like the plot of a science fiction blockbuster, but this is the cutting-edge reality of modern astrobiology. Welcome to a journey that spans from the microscopic life inside our planet's crust to the vast swirling atmospheres of worlds trillions of miles away. In May of 2026, the city of Madison, Wisconsin, will transform into the global epicenter for the quest to understand life's place in the universe. The American Geophysical Union is set to host the 2026 Astrobiology Science Conference, often referred to by the community as AbSciCon 2026. This massive gathering at the Monona Terrace Community and Convention Center will bring together nearly 900 scientific experts, researchers, and pioneers from every corner of the globe. From May 17 to May 22, these explorers will dive into the unknown, investigating everything from Earth's deep past to the potential for life on distant icy moons and beyond. The American Geophysical Union has ensured that this event is accessible to both the scientific community and the global press through extensive media outreach. For reporters and science news officers, this is a prime opportunity to witness history. Whether you are an established staff journalist or a freelancer who has published at least 3 science stories in the last 12 months, the American Geophysical Union is opening its doors for registration. Even for those who cannot make it to Madison in person, the conference is embracing a hybrid model. Online-only discussion sessions will be hosted on Zoom, and for those in different time zones, recordings of the audio and slide presentations from in-person town halls, plenaries, and oral sessions will be available on demand roughly 72 hours after they conclude. But what exactly will these 900 experts be talking about? One of the most fascinating topics on the agenda is the study of biosignatures, the chemical and physical signs that life leaves behind. Starting on Monday at 2 o'clock in the afternoon in the session titled Assembly Theory Across Scales, Estelle Jani and Gage Siebert will be discussing molecular construction versus algorithmic complexity. This is a groundbreaking method of distinguishing between biological and non-biological processes, which could be the key to finding life as we do not know it. But the research gets even more unconventional. On Monday afternoon at 3:45, Fred Sharp will present findings on humpback whale night thrums, exploring how these non-human signals might help us identify technological signatures from civilizations beyond our own. Felisa Wolf-Simon is also investigating tiny magnets found inside bacteria, which could serve as a biological indicator for life on energy-poor exoplanets. Meanwhile, researchers like Jasmina Viman and Laura Barge are looking backward into Earth's own history, decoding the chemical fingerprints of our planet's earliest life to learn how to spot similar signs on alien worlds. The conference will also shine a spotlight on the extreme environments of our own planet, which serve as perfect laboratories for alien conditions. On Tuesday at 2 o'clock in the afternoon, William Brazelton will share the staggering results of a recent drilling expedition that successfully located living microbes an incredible 1 kilometer deep within the seafloor. This discovery challenges our understanding of the limits of life itself. How do these organisms survive in such isolation? Kambiz Kalhor is studying the extra-stable enzymes that allow these sub-seafloor microbes to endure for millions of years in deep sediments. On the other end of the environmental spectrum, Angelique Ray has found soil microbes on mountain summits that actually use hydrogen gas to generate energy. There is even research from Kayla Sorensen about microbes that might subsist on oxygen produced directly by rocks through chemical processes. And in a mission that sounds like a tribute to the legendary desert world of science fiction, Jani Raidboer and her team are searching the dunes of Alaska to find clues about how life might survive in the alien sands of Titan, Saturn's largest moon. The story of life's evolution is also getting a radical rewrite during this conference. Rohan Shiradonka is looking at how photosynthesis might work using infrared light, which could dramatically expand the so-called red edge of habitability. If plants on other worlds can grow using light we cannot see, the number of potentially habitable planets could skyrocket. Fouad El Baidouri is investigating why multicellularity seems to be a repeat-winning strategy in evolution, while Myrene Barrero Arevalo asks a mind-bending question. Could life have started without genes? If so, would Darwinian evolution still apply? Olivia Smith will even discuss the possibility of entire worlds consisting of just one single species, a biological monoculture that defies our expectations of diversity. When it comes to distant worlds, the challenges of detection are just as great. Ana Lobo will present research on Monday showing that identifying life might be significantly harder on planets that experience extreme boom-bust seasons. However, Jonathan Jernigan notes that these same extreme seasons might actually boost marine life while limiting life on land. Paul Rimmer will take us back to a Haitian early Earth, suggesting that our own planet might have once had a short-lived hydrogen atmosphere that set the stage for all life to follow. And in a clever test of our detection methods, Chase Cooper will describe how a lunar orbiter observed the glint of Earth's oceans, proving we can find exo-oceans on other planets by looking for similar light reflections off their surfaces. This is a monumental effort by the American Geophysical Union to bridge the gap between the abiotic and the biotic, between cold rock and living breathing organisms. If you want to keep up with these incredible discoveries from the very edge of human knowledge, make sure to hit that subscribe button and turn on notifications right now. Every piece of data from the depths of our oceans or the peaks of our mountains brings us one step closer to answering the most profound question in human history. Are we alone? The ultimate goal of the nearly 900 scientists attending the Astrobiology Science Conference is to determine if life is a cosmic fluke or a fundamental, universal certainty. The presentations in Madison are building the roadmap for the next generation of space exploration. But the journey does not end there. The American Geophysical Union is already preparing for the future with the Japan Geoscience Union and American Geophysical Union joint meeting in Japan from May 24 to May 29. And the American Geophysical Union 2026 annual meeting in San Francisco from December 7 to December 11. The American Geophysical Union is a global community supporting more than 500,000 professionals and advocates in Earth and space sciences. Their mission is to advance discovery and solution science that accelerate knowledge while remaining ethical, unbiased, and respectful of communities and their values. The search for our place in the cosmos is accelerating, and the answers might be much closer than we ever dared to imagine. As we uncover the secrets of the deep sea floor and the high mountain peaks, we are effectively learning how to read the language of the universe. What do you think is the most likely place we will find alien life? Is it deep in a subsurface ocean on an icy moon, or orbiting a distant red dwarf star? Let us know your theories in the comments below. Don't forget to like this video and share it with your fellow space enthusiasts. We will see you in the next one as we continue to unveil the mysteries of the deep.